I'll probably give you the handouts for next time too, because I'm not sure when I'll have time to put those together. So, all right, let's see. So these are a couple of calculator things. So we're talking about quadratic inequalities. Okay, so what we're going to do with this is we have a function here that says the height. This is a quadratic, so it's 304 minus 16t squared. And this is a sort of a calculus problem in a sense, but it's something we're going to do with technology like we've been doing. Okay, so actually this just says the rock falls from a tower 304 feet high, and the question is how many seconds will it take for the rock to hit the ground? Well, actually this one you could do without a calculator. I'm gonna do this with a calculator and then show you what you do. So I'm going to put in, if you brought your calculator, you probably ought to just put this one and the next one in. So we have 304, and then we have minus 16t squared. Well, you have to put in x squared, of course. Okay, so we'll put that in. And this will end up being a quadratic, goes upside down like we'd expect. Now, you got to think about the window on this. The window, x is time. So the lowest time is 0. You don't want to have negative time. And I'm just going to take a guess. I have no idea at the start of this. I'm going to say like, maybe it's 10 seconds. Maybe that's too much. And then I'm going to scale by 1. And the 304 is actually the starting point. And then it's just going to go down. So to me, that would tell me that my y needs to go 0 maybe to something bigger than 304. So I'm going to say something like maybe 350 or something like that, okay, and then maybe scale by 50. So let's try that window and see if that gives us a good picture of what's going on the graph then, okay? All right, and what you should see on here is that looks like a good picture, okay? So you've got the 304 here, and then it's just going down. You got to find out how long it takes to reach the ground. Okay, well, it reaches the ground at this point right here. I mean, that looks like 1, 2, 3, about between 4 and 5 seconds. That's what I can tell from my graph. So I'm going to have you just do two things here. First thing is just sketch a graph. It doesn't have to be perfect or anything. All I really need to see on your graph is, you know, this is the time. And let's see, that is in, does it say? Yeah, it says seconds. So that's the time in seconds. And then this is the height in feet. Okay, so basically on this, you can just go out to 5 if you want to. You can just make a sketch. It doesn't have to be perfect. And we were going up to 350, and that's probably good enough. Okay, this would end up being the height like that. Okay, so what you do on this then is you're going to find how long it takes for the rock to hit the ground. Well, really all you do is you just set h equal to 0. Okay, and then you'll have an equation we solve. So we'll have 0 equals 304 minus 16t squared. Okay, and then we can get it exact. Okay, you can tell by the calculator it looks like between 4 and 5. Okay, now we've learned how to solve different types of quadratic equations. This one to me is just square root property. Okay, no factoring anything. Just, you know, move the t squared the other side. So you would end up getting 16t squared equals 304. And then you can divide by 16. And we'll just use the calculator because more than likely we're going to get some decimals on this anyway. Okay, so I'm just going to take 304 divided by 16. And then that'll give 19. And then, of course, what you do is square root of both sides. So if we do the square root of both sides, then we'll just round that off maybe to like 1 decimal or something like that. So on my calculator, square root of 19, I'm getting about 4.4 seconds. And that makes a lot of sense. Based on our graph, that looks pretty accurate. Okay, does that make sense to everybody what it did? Okay, that was pretty simple. Okay, there's nothing to do other than just set that height equal to 0 and then solve the equation. So that was pretty simple. Okay, any questions on that? Okay, all right, the next one, let's see. This one I think we got to do, this one's more like an inequality. So on this next one, we've got this function, which is a little different, negative 9.8 t squared plus 49. And then it says, during that interval, what time will the rocket be higher than, and that kind of tells you got an inequality, 58.8 meters. So we're going to do this graphically. We need to do this one graphically. So same idea. Let's put this in the calculator. You can erase what we had in the last problem and just put it in. So we'll have negative 9.8. And that would be t to the second, so we're going to use x to the second. And then this is plus, it looks like 49t, so we'll put in 49x like that. Okay, we may have to adjust our window. So if you use the same window from the last problem, that's not the greatest window. So let me have you adjust this a little bit. I'll kind of tell you what to do. We probably can go up to 100, so let's just go out to maybe like 6 might work there, it looks like, and then I think this can go up to 100. And then I'll scale this by 10. Okay, you can use the same viewing picture that we have, but I think it's more viewable if you do it this way on this problem then. Okay, so I'll put the window over there if you need to refer to that. And then we'll put in that in the graphing calculator, and then we're just going to construct a graph on that. Okay? All right, so the thing about this is when is it going to be greater than 58.8 meters? Well, so here's the idea. This is meters. I'm looking at this right here. So what you would have to do is probably graph the 58.8. You would have a line, and then you should be able to figure out that interval where it's above that then. Okay, so what I'll have you do is this, go to Y2, and then put in 58.8. Okay, now that's going to give a horizontal line, and then that would be the sketch of the graph that I want you to do on that then. So just put those two things in, graph it, and I'll have you just do a kind of a sketch on that. And then we can use our technology to figure this out then. Okay, so really for your sketch, all you need to do is something kind of like this. This is going out to 6, and that is in seconds. That's the time in seconds. And then this is meters, so this is like the height in meters. And let's see, this is right here. This is the 58. So you might label that as y equals 58.8 like that. Okay, so the idea with this is we're trying to figure out when the rocket will be higher than that. So what part of the graph is that? Is that the, describe for me which part that would be on the graph. Because that right there is 58.8. What part are you looking for then? Is anybody awake? Okay, this part right here, right? Okay, that'd just be there. So what we need to do is just figure out that x value and that x value. And we can do that on the calculator, but we can also do that, you know, with by hand with quadratic formula, but I'm not going to really bother doing that. I'm just going to mention what you could do. If you did this by algebra, what you would do is you would just take this equation and you would set the height equal to 58.8 and then solve that. And that's probably a quadratic formula problem, but I'm going to choose not to do it that way since it's technology anyway. So what we'll do with this then is, and I don't know if we've done the intersection yet in this class or not, so if this is new to you, you might want to write this down. What you can do is you can just go second, I'll write down the keystrokes, you go second trace, like this, and then you should find an option that says intersect, number 5, and this is kind of the easy way to do this with technology. Then you just press enter. So you can try this with me if you want to. And what you're going to do is just kind of adjust it. Right now it's on the blue curve, so just get close to that intersection point, press enter. It should skip back up to the line, and then you press enter again. When it says guess, press enter again. You're going to know you've done this right because it should blink on that intersection point and tell you what it is. So what I'd like you guys to do is just label that point as 3 and then 58.8. Okay, that's what you would get if you solved that quadratic equation anyway. Okay, then you got to repeat that again. So you would now go second trace, start over again, go to option 5, And then this time, just move the cursor so it's closer to that intersection point on the left. Okay, press enter. Again, it should pop up on the red line. Just press enter again. When it says guess, press enter again, and then that's 2. Okay, so probably we could have done this without the quadratic formula if you got, you know, the answers 2 and 3 on that. So that would be the idea. Does that make sense what I did on my calculator? Is that working okay? I don't know if we've done that this semester yet, but you can find the intersection between 2 curves by doing that then, okay? So basically what you would say then is you would just say on what interval? Well, the answer would be from 2 to 3, okay? That would be it. Okay, so from 2 to 3 seconds, that projectile is above 58.8 meters. That's the meaning of that. Okay, does that make sense to everybody? Okay. Okay, that's just, since we're doing inequalities in here, there's just a few applications I've given on the homework of inequalities. This is kind of a typical one that you can look at. Okay, any questions about that then?